Hello class, today I'm going to go over a quick explanation of what we mean by degrees of freedom. Like, what does that even mean? Why do we come to this overall kind of justification for degrees of freedom equals n minus 1 in most cases? I mean, thus far, if you've already experienced this term, we've basically seen that the short formula for degrees of freedom equals n minus 1. But what does that mean? What are we trying to kind of say when we say, oh, degrees of freedom equals n minus 1? I'm going to give it to you very simply here. Say that I have a data set with 5 elements in it. So this is 5 numbers. We don't know what those numbers are yet, but the overall mean of that data set is equal to 10. Already I know, before I even know what any of the numbers are within my data set, that the overall sum of the data set has to equal 50, because 50 divided by 5 is my mean of 10. 10 times 5 equals 50. Okay? So far what I know is that if I have my 5 elements here, 3, 4, and 5, they have to equal 50. And what the degrees of freedom is basically asking is that it's this problem of, well, how many of these elements within your data set here can be freely selected and still give yourself a sum of 50? Okay? And so we're trying to find the maximum number of elements that we can freely select that will still give us this sum of 50. And if you already can kind of put together here, basically all of the elements except for one can be freely selected and we're still able to get to our sum of 50. And I'll show you here. So I'm going to create a random sample here, 200 minus 50, 3, 1, and then I'll have x. Okay, so I'm going to sum these all up here really quickly. So I have 200 minus 50 plus 3 plus 1 equals 154 plus x equals 50. Okay, and what we see here is that now that I've kind of shortened this down to, this could be a data set of 1,000 integers. It doesn't really matter. At the end of the day, what I'm going to have is the sum of the n minus 1, and then I'm just going to correct now for whatever this number is by basically doing a little bit of algebra here. So 154 minus 50 equals x, and so x equals 104. Okay, so I've been able to figure out that the degrees of freedom here is 4, okay? Because what I have determined is that I can freely select 4 out of these 5 elements and to put any random number I want in here and still be able to get a sum of 50 by basically controlling for what the 5th number is going to be. So you can try this out yourself. You can put any random 4 numbers in here, and then at the end you're still going to be able to generate some number that is going to get you to that 50, which is basically then going to give you that mean of 10. And so this is what we mean by degrees of freedom. We're essentially trying to figure out how many numbers we can have at random, because most of the time our data might be fairly random, and we're still trying to figure out, okay, if I'm going to calculate a mean or if I'm going to calculate some test statistic, how many of these numbers can I have free while being able to still account for what the output needs to be, and that is this n minus 1. Why we do this gets a little technical, but when it comes to some of the questions you might face within the homework and the exam, this is going to perhaps help you very quickly kind of understand what we mean by degrees of freedom in n minus 1, and this is one example of how we do that. If you have more questions about this, feel free to reach out to me. I hope this gives you a little bit more clarification of how this is done and what we mean by this term degrees of freedom, and you can quickly apply it within the homework and the exams. All right, talk to you later. Bye.